Hi guys, welcome to my channel. In this video we are going to analyze a question. It's about structural analysis. The question will be analyzed due to moment distribution methods, and you can see there's a frame, so let's analyze the question. The first, I'm going to specify my stiffness factors K dA. You can see dA, that will be equal to 4 EI over 12 EI over 3. Okay, yeah, from DC I'm going to have a stiffness factor from DC, and it will be 3 EI because I'm going to use modified over L, that will be EI over 4. And from dB, K dB will be equal to 3 EI, yeah, over 12, and equal to EI over 4. And now let's find the distribution factors. For the distribution factors, dA, it's going to be dA. For dA, that will be EI over 3 over EI over 3 plus EI over 4 and plus EI over 4. Okay, and now this is going to be 0.4, and for dB, for dF dB will be equal to 4 EI over 4 over EI over 3 and plus EI over 4 and plus EI over 4, and that will be equal to 0.3. And when I take the subtract from the 1, 0.3 and 0.4, and this is going to be minus D for DC. Okay, yeah, for dF DC is equal to 0, and dF DC will be equal to 0.3 also. So now let's write the distribution factors. For distribution factors for the fixed part, you can see for the fixed part, that will be equal to 0. And for the CD is a pin part 1, and BD also is a pin part 1. And this is going to be 0.4, this is going to be 0.3, this is going to be 0.3, okay? So let's find the fixed end moments. Fixed end moments for AB, I confused, for DA, For DA, it will be WL square over 12, okay? 4 times L square, 12 square over 12, and it will be 48 gives feet, sorry. And now let's calculate for, of course, for DC. For DC, that will be also WL square over 8. You can see from this, WL square over 8. Actually, I don't need to write the formula. W4 L square is 12 square over 8. This minus 72. And fixed end moment, AD is equal to minus 48 gives feet, okay? So let's write the fixed end moments on table. Minus 48, and of course to DC that will be minus 72, okay? Yeah, and this is 0, this is 0, and this is 0. So now I have my fixed end moments. Now I'm going to distribute them. So let's do it. For this one, I'm going to take the summation of 48 and plus 72, okay? 48 minus 72, it will be minus 24. When it's multiplied with 0.4, that will be 9.6, because you know I'm going to do something like that, times 0.4 times minus 1 is 9.6, okay? I'm going to do for the all of them. So I will take this one. It will be 7.2 when I 24 my times. Let's do it again. 0.3 times minus 1. It's going to be 7.2. Okay, and this is also the same, 7.2. So now I'm going to make a carryover. You can see I cannot make any carryover to here. That's going to be 0. That's going to be 0 because this is modified formula used here. Okay, so I'm just going to make a carryover to that. And this is also 0 because when I multiply with this fixed moment with its own distribution factor, it's going to be 0. And this is going to be 4.8. Okay, and this is also 0, 0, 0. And now for the moment, that will be minus 43.2 and 57.6 and also 7.2, and this is also minus 64.8. And now I got my moments. So if I got moments, let's try to find the shears. I'm going to write shear here. For the shear for the first part, okay, for the first part, it will be from A to D, okay, A, D. I have a force 2 times 12 and 48. I have a moment at this direction 43.2. I have a moment here 57.6. And I have this one. This is going to be the left. So total moment at A is equal to 0, and this direction is positive. So I'm going to write like that: 43.2 minus 57.6 minus 48 times 6, because you know this is 6 and this is 6, and of course plus VD left, yeah, okay, sorry, VD left times, we didn't multiply with the moments R, VD left times 12 is equal to 0, okay? So from this equation, I'm going to obtain VD left as 25, yeah, 25.2, okay, 25.2. That was correct actually. 25.2, and when I take this equation, total Fy is equal to 0, and 48 minus 25.2 and minus VA is equal to 0, so VA is equal to 22.8, okay, 22.8. And now let's make the calculation for the second part, okay, for the second part, from D to C. And now I have also a force here, 48, and I have a moment as from D to C. From D to C is 64.8, and this is 0, okay, this is 0. So I'm going to take as the total moment at C is equal to 0. 64.8, okay, plus 48 times 6, okay, minus VD right times 12. Because you know this is 6, and this is also it's 12. And this is equal to 0, and from this equation I will obtain VD right as 29.4, and from the total Fy is equal to 0, 48 minus 29.4 minus VC, this force is equal to 0. So VC will be equal to 18.6 kips. And let's do it for the last part. Let's do it for the last part. And this is also will be from D to B. From DB I have 7.2 as moment, but that won't be in that direction. Sorry. That will be in this direction. And I will take the moment at B is equal to 0. This is positive. Sorry, I forgot to write here. This is positive. Yeah. 7.2, sorry. 7.2. This is minus. And this is plus BB, okay, times 12 is equal to 0. And, sorry, excuse me. Something is wrong. It's going to be VB. I take the respect to the B, so I'm going to calculate with VD, okay? Yeah, VD times 12 will be equal to 0, and VD will be 0.6. And from this equation, so total Fy is equal to 0, 0.6 plus VB is equal to 0, VB is minus 0.6. Okay, so now I calculated the shears, so let's draw the shear and moment diagrams. I'm going to draw them here. Start with shear diagram. I'm going to draw them all separately. Okay, for now I'm going to raise up at A. What I have at A as a shear, 25.2, okay, 25.2. So I'm going to decrease as 48. And because, you know, it's distributed, so it's going to be as a something like that. And this is going to be 22.8, okay? For the first part, this is A, this is D, for the first part. So let's draw for the second part. I'm going to draw it here because it was so top. And for the second part, what I have VDC. VDC as 29.4, okay? 29.4. And I have also another distributed load as 48. And I will decrease as 48. And I'm going to obtain 18.6. And the last part, sorry, this is DC. For the last part, shear diagram. This is going to be D, this is going to be B. And I have 0.6, sorry. I'm going to write the letters down. This is for D, B. I have 0.6. I will go on with 0.6. There is no any force when I reach the point B, and 0.6 is downward, so, and I will close. Now this is my shear diagrams, so let's draw the moment diagram also. For the first part, moment diagram. For the first part, I have a moment as 43.2 at this 43.2. This distance is 5.7 and this distance is 7.35. You know how to find that. It comes from the similarity of the triangular. Yeah, you're gonna take the ratio of this to this and ratio of this to this, okay? And for this one, I will raise up. For this one, I will raise up at this amount of area, okay? This amount of area. So what is this amount of area? 25.2 times 5.7 and divided 2, I will obtain, and I will raise at this amount, and I will reach this point. What is this point? 21.8, okay? When I reach this point, I'm going to decrease at this amount, okay? This amount of area. So that will be, for example, 6.3 here, okay? It's going to be 6.3 here. Yeah, sorry. And I'm going to decrease at this amount of area, this amount of area. When I decreased, I will obtain 57.6, okay? Now this is okay for the first part. Let's draw for the second part. For DC, no, 1 second. For DC, this is D, this is C. And now I have a moment at DC, 64.8, okay? And I will raise up at this amount of area. I will raise up at this amount of area and then reach 43.2. I reach 43.2. And I'm going to goes down at this amount of area. I'm going to decrease at this amount of area, and I'm going to come to 0 because, you know, this is a roller connection. In the roller connection, there is no moment, that it has to be 0. So I will decrease and stop with this one. And let's draw also for the last part. At the last part, I have a moment here, 7.2, right? 7.2, and you can see that there is this shape. This shape is a rectangular, so it is going to be a triangular. So I'm going to decrease as triangular. Okay, I'm going to 0.6 times 12. That will be 7.2. So that means, sorry, I'm going to draw it as linear because it has to be linear. So I draw it, come to 0 because B is pin and C is roller. So there is no any moment at this supports. Now the question is that, thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. Thank you for your help. Thank you for watching me. See you later for the next question.